Welcome to Solving HPC Challenges in Health Life Science through Scalable Compute Architectures. I'm George Tai, the Intel Regional Sales Director for Health Life Science Asia Pacific. We're going to go through a few disclaimers, so take a look at a few seconds for the disclaimers. So what are we going to cover today? We're going to cover a few of the challenges we see in health life science. And I'll also spend some time to explain what is unique about collaborating with the ecosystem and how to translate to value for the HPC health life science needs. I'll also try to end early. If we have any questions, we would love to cover that as well as we go through our presentation. As you know all too well, there's never been a more challenging time for HPC users. Market pressure itself isn't new. The pandemic, the race for innovative processes for drug discoveries, tracking changes in virus genomes spurred the need to invest in health life science and HPC for health life science, and to tackle the most scientific challenging problems. With the complexity in approaches, whether it be a traditional HPC big data analysis or a cloud-native AI infrastructure, lends us to investigate what does it mean to have scale and simplify an HPC infrastructure. Now, businesses have to evaluate new trends, technologies, and approaches to deep learning, and how does that apply to genomics, and very quickly turn those challenges into opportunities. Intel has invested significant resources and talent to collaborate with the ecosystem to drive those new opportunities for your end customers. Let's take a look at how those specific goals and challenges are for health life science. When we did our analysis and talked to researchers' needs, we found a few common goals researchers have identified. First, we need to run a broad range of applications with various systems requirements. Second, data sets are increasingly more complex and growing in size. Third, the fast result times are required. And finally, we need to do it cheaply and with scalability to help reduce total cost of ownership. So how do we get there? Intel's focus is to drive increased throughput per core, meaning higher performance and more efficient products. We need to increase memory bandwidth and capacity, and working with the framework ecosystem to leverage these optimizations, and finally incorporating AI throughout the whole workflow. I will introduce our work with the Broad Institute, the creator of a widely used genomics application toolkit called GATK, and how Intel and the Broad collaborated to drive value for the health life science HPC ecosystem.
The mission of the Broad Institute is to propel the understanding and treatment of human disease.
The Broad has amassed and produced one of the largest resources for genomic data in the world. To do that was a huge challenge computationally, and without Intel, we would never have been able to do that. In previous attempts to aggregate all that data, we weren't able to process more than a couple thousand human whole genomes. So with Intel's Optane SSDs, we're able to speed up that piece of the pipeline several times faster. We're not just trying to stream bits across the internet. Our team at the Broad here is something close to 50 petabytes of genomic data.
Cloud computing has become really enormously important to what we do. Having data stored in the cloud has given us tremendous advantages of scale and cost, but it's also opening it up to the broader community. And so researchers who wouldn't have before will be enabled. This is really the advantage of sort of many eyes looking at a data set and being able to tackle really hard problems.
We decided to open source the GATK, the Genome Analysis Tool Kit, so that researchers around the world will use it and the entire world could push the boundaries of science together. So
the idea is that by building up large reference databases, we can essentially create lookup tables. The approach is to study DNA in a comprehensive, uniform way and to try to associate that to patterns of disease. So with our cloud-based tools, it might indicate a certain treatment or a certain sort of diagnostic outcome. So this could really advance our understanding of human disease. And I think that's only going to improve.
What is GATK? It's a toolkit used in over 90% of the world's genomics workload, with many thousands of registered users to determine structure, function, evolution, and mapping of the genomes and exomes. It is highly used in life science to do gene screening and diagnostics, screening for cancer and inherited rare diseases, used to determine drug tolerances and pharmacogenomics, and process and qualify control of high throughput screening data. This is the website where we can find information on GATK. The Broad and Intel, as well as the community, has invested significant resources to drive optimized applications for optimized performance and better user-developer experience. The Broad Institute with the most popular Genomics Analysis Tool Kit, GATK, is an example of this, and Intel and its ecosystem will continue to raise the bar and drive new roadmaps to accelerate the area of genomic analysis in HPC. Let's take a closer look of what it means by HPC. That is, what organization like yours have to think about when building and strengthening their HPC environment. Clearly, there's a lot of more performance than just one piece of technology like a chipset or a software tool or an accelerator. A performant HPC environment stands on multiple pillars, not just one or two. These pillars need to be strong on their own and strong as they interoperate together. As Intel, these has taken a lot of resource and time to optimize for each of these pillars. There's no broader portfolio available for HPC, both in and what we offer now and what we are also continuously building. In particular, we offer the widest range of architectures engineered to deliver the best performance on your HPC workload, with a range of built-in and external accelerators for performance boosting, including not only just CPU, but built-in AI acceleration, are widely used software tools, including Parallel Studio XE and the multi-architecture programming model for unified development across all architectures, also known as One API, will be used to simplify and allow scalability and flexibility across all Intel architectures, allowing you to build once and for all. Our groundbreaking memory technology boosts performance for challenging workloads in both HPC and AI. And with DAOS, we've re-architected the memory and storage hierarchy to enable converged workloads that combine traditional HPC simulations with analytics and AI. Our innovative interconnect suite includes CXL, high-performance interconnect specialized for high-bandwidth devices like GPU, as well as our Ethernet 800, also known as Columbiaville, for unbeatable price per performance. Finally, Intel's hardware-based benchmark-defining security is there to help build business resilience and optimize any risk from any type of DDoS attacks or any type of risk in security, with real-time encryption and no performance overhead from software-only mitigations, and all delivered by an industry partner with deep roots in HPC and AI, invested in where all these fields will grow in the short and long term. Intel takes a holistic approach to accelerating computing, from built-in AI acceleration on Xeon to our FPGAs for accelerated key workloads and adapting to a changing requirements. And with our new category of GPUs purpose-built for data centers, artificial intelligence, and HPC workloads, we round out the acceleration portfolio for our customers. As we talked about earlier, Xeon Scalable is not only a CPU with built-in acceleration for HPC, but it also includes AI workloads and supports AVX 512, which helps on both Intel's deep learning boost with VNNI to accelerate AI workloads. Testing showed 9 times performance advantage with deep learning boost for inference. So while Xeon's a great purpose for CPU and HPC, it's also a powerful accelerator in Excel for a diverse range of workloads. Moving on to our upcoming GPU, we're very excited to be bringing customers to this newly accelerator-based on XE microarchitecture. This is a purpose-built for AI and HPC. This highly flexible discrete HPC accelerator will be Intel's first product to use 7nm technology and will also leverage advanced Foveros packaging technology to combine dies built on multiple technology nodes like 7nm and 10nm, and in addition to deliver excellent vector compute capabilities. This accelerator will incorporate dense systolic arrays, enabling large speedups for matrix computing tasks, and we're also debuting Ponte Vecchio in the Aurora supercomputer in the US this year. Intel Stratix 10 FPGAs deliver innovative advantages in performance, power efficiency, density, and system integration. Companies in Taiwan like Wasai feature accelerated GATK tools on FPGA to deliver both high-performance single whole genome sequencing runs while enabling a unique hybrid infrastructure and performance per whole genome sequence, and parallelized computing via Xeon. Wasai, Advantech, and GARAOTUS work with FPGAs to deliver up to 2 times performance gains per previous generation. FPGAs combine the programmability and flexibility of SYSTEX 10 and SoCs with 3D stacked high bandwidth memory to HBM2, enabling high performance core fabric that can utilize the bandwidth from an in-package memory tile for high memory use cases in health life science. And finally, we have a one API rolling out, which is developers gain a unique experience to program across all XPUs and accelerators, speeding and simplifying the process of optimizing code. The relationship with software providers and developers is a key factor for how we overcome the challenges in high-performance computing and health life science. We all have a common goal to accelerate new discoveries and a drive to progress human society. Partners like GARAOTUS work with Intel to drive optimizations of their solution and code on Intel architecture. Advantech is an example of how we work with Intel and GARAOTUS to pre-release hardware platforms and ensure that applications deliver proven and optimally performed workloads for our end customers. We also invest in HPC applications that you're already getting better performance right out the box. Here's a list of some of our ISVs, open source codes, and AI framework we leverage to get better out-of-the-box experience. As we mentioned, Intel and GATK work tirelessly to bring out the value of HPC and genomics for the research community. Both hardware and software are key focuses when working with GATK version 4. An example of an optimization is this immensely large whole genome sequencing file generate and the ability for GKL, which is compression and decompression of data. We can see that GARAOTUS and Advantech and WSI implemented a very unique solution for select solutions for genomics. I want to now introduce to you Intel's latest Xeon processor to enhance the HPC. Ice Lake is Intel's key focus product this year to drive compute, memory, I/O frameworks, and enabling the ecosystem. End users in health life science can now benefit to reach insights quickly, run diverse workloads, and improve the ROI of the system. We can see the implementation with GARAOTUS and Advantech and WSI in their upcoming genomic appliance solution available soon. Here is an example where third generation Xeon is being used in our region in APAC. As part of Japan's Society 5.0 initiative, supercomputers for AI and HPC is being used to contribute to research in medical, natural disasters, and smart cities. Together, as an HPC community, we want you to leverage Intel as a strong partner as Intel supports the industry through long-time commitment in our OEMs, ODMs, and CSPs, cloud service provider relationships across engineering and business. There are over 90 plus countries with resellers and over 100 plus HPC and AI channel specialists that can support training, resource, and business collaboration. GARAOTUS has specific and strong presence in APAC to enable such partnerships in today's with ISV and HPC collaborations. This matters as end customers depend on trusted confidence in hardware and supplier relationships to achieve maximum performance to solve their most scientifically challenging problems. Together, we hope to continue to elevate and drive for a better future to enable scientific discoveries. In closing, Intel is excited to be your partner as an HPC environment evolves. We keep our customers to win and invest in our technologies and people and partnerships required to drive real value for high-performance computing. We're investing in the foundational technology you need from CPU to packaging, and we're investing in innovations you need from XCPUs and beyond. HPC customers really need three things: technology products that deliver reliable performance, open tools for building and optimizing code, and a path for unlocking the potential of new opportunities like AI. We believe together the ecosystem can deliver great value to the scientific community. I'll now present to you a very tangible next step. In working with Intel is you can try a Intel reference design, also known as Select Solutions for Genomics Analysis. With a reference architecture and installation guide in your hand for applications, the journey from procurement to deployment to service delivery is faster and easier than before, allowing more time and resource for innovative enhancements specific to workload use cases. With genomics, Advantech, GARAOTUS, and Wasai provide a unique and scalable solution for your health life science genomics HPC need. This is where you can find out more information. And thank you for our talk today. Thank you.